Greetings and welcome, friends. We've been talking about normal distribution. It is amazing. I love it. I love it. And we can represent the area under this normal bell-shaped curve. It represents 100% of the possible outcomes. So the area under that curve you could think of as 1 because 1 is the same as 100%, perhaps. And then we actually have this little chart over here that describes different regions within that curve, where the measure of center for normally distributed data sets that we would use, Ben, it would be the mean, right? Here it's called mu. Perhaps you are remembering it being called X bar. And then we talk about the percentages that are 1 or 2 or 3 standard deviations. That's what little sigma represents, above or below the mean. All right, and so we've got those percentages. Now, we don't want to only relate this to general, right, variable speak, right? We want to actually eventually put some real numbers in there and then start applying these concepts. But they do have us practice with that first. So here's question 6. It says, give the percent of the area under the normal curve represented by the shaded region. There we go. So here's some shaded region here, right? And if I match this area to over here, it looks like that's 13.5, 13.5. Question. All right, sorry. That's why I think I showed you some of those yesterday in class. I'll have to make sure the printing comes out a little bit better next time. Add those together. 13 times 2. Ben, put your phone away. Is 26 plus half times 2 is, going to be 27% of the data lands in those regions. On the test, you will have this chart. Actually, I'm going to give it to you today. Here is question 8. It says, a normal distribution has a mean of mu and a standard deviation of little sigma. Oh. Find the indicated probability for a randomly selected x value. So this p is function notation. We'll learn about that elsewhere. But the probability that any value x is greater than or equal to the mean minus 1 standard deviation. So if this is the mean, I'll call that x bar. We could call it mu. 1 standard deviation less than that is right here. And so they want to figure out what's the probability that we would be greater than that. So I might represent this a couple different ways. I think this is the way I would do it. I kind of like to think about these in terms of area addition postulate. I might think about it as this region plus this region. Do you guys feel like that's believable? Nice. What is this region represented as? Well, slow down. It was a part of my normal distribution graph, so it's symmetric. But yeah, that part, if that's what a data set looked like, would be skewed right. But what percent of the data does that represent? And that this way. Exactly half. So 50%. And then what percent is just this region here? 34%, yeah. No, you're right. It's 34 right there. Or you could think about it as half of 68, which is also 34, right, Jimmy? Jimmy. This is Jimmy. 84%. That was a quote from the classic 1998 video game StarCraft. Amazing game. Let's see. Here we go. Then they ask, what's the probability that it is the mean minus 1 standard deviation? That's right here. That x is between that and the mean plus 1 standard deviation. This one's actually an easy one once we interpret what it means. So I gave you the graph to shade it, and that's actually just straight up 68%. See, I'll make... No, you fixed it yesterday in class, remember? Yep. That's what we were supposed to do. Here we go. It says a normally distributed set of data has a mean of 33. So that's my measure of center. So here's 33. Actually, both of these are going to be 33. and a standard deviation of 4. So that means from here, I'm just going to keep plus 4ing to get my new kind of locations on my curve. And over here, I'll subtract 4, subtract 4, subtract 4. So 33 plus 4 is 37, plus 4 is 41, plus 4 is 45. You guys writing this down if you didn't do your homework? It was a devastatingly heartbreaking number of you. Moment of silence for all the homework that didn't get cared for last night. So, so here's my distribution. Actually, watch this. Cheat sheet. Beep. Bing. And that was so fast. Sleight of hand. I'm a magician. Actually, you know what? I feel like going purple here. Represent PUHS. Cool colors. Purple. What's the probability that a data set is between 29 and 37? Can I help you? I'll be right over. Yeah, thanks. So this right here is 68% of our data. What if it says at most 21? At most 21. Yeah, we've got all sorts of special guests and visitors today. Don't be fooled by the front label. It's the inside that counts. Don't judge the book by its cover. Right there. You got that. All right. So, guys, if it's at most 21, then that means that I'm talking about all the data that's less than 21, okay? Less than 21. What does that refer to here? What does that refer to here, guys? Well, let me show you my pictures right here, right? Yeah, 0.15%. Well done. Well, thanks for watching, Internet friends. Have a great day.